All right, class, here we go. So definition one of the trig functions here, 1.3. Finally, we got to trigonometry. So just like we did before earlier in the class here, you guys tell me. Oh, hold on. It's no longer a triangle, is that right? So can you kind of think of maybe possibly it kind of be forming a little triangle right here? Like if you did drop a altitude down like this, boom. So then instead of a triangle, we do have the, oh, okay, hold on. We have the x coordinate. We have the y coordinate. Is there a way to get the distance from here to here? Yeah, we have a distance formula. Now we're not going to do it now. We're just going to label the value for it. We're good? And it's just going to be value of r. That is it. And how come my tools? There it is. Okay, we're just going to label it as r. Okay, so I'm going to go like this off to the side here. I'm going to list the trig function. Then we're going to list the abbreviation for it. We're going to come up with it. And then we're going to list the ratio of it here. So definition one of the trig functions has to deal with, we call it the x and y coordinate. We're good? That's what it really is. Okay, so as a person, who invented trigonometry again? What's the guy's name? Hipparchus. Hipparchus invented trigonometry. Some guy. Okay, so what he did is he named it. It's not named sine. He named it something else. And in fact, sine is a fun one because sine actually goes back all the way to the Babylonians and some Arab mathematicians as well. So when it comes through, it was actually called Jibba. Was the first pronunciation of it. And then after a mistranslation of certain things, it turned out to be sine. So now we just call it sine. And it's just S-I, Jibba. If you want to call it Jibba still, that's okay to me. So sine. So we say sine of theta. So notice the angle measurement is what we are inputting, right? And the output is going to be some kind of ratio. Okay, so the best way to abbreviate this here is we can use the first letter, we can use the first two for the first three, and we decided to use the first three because we're going to have things. So the first three letters taken for that guy. And sin is different. So we still say sine, even though it looks like this. Good. So it's just we just knock off anything else besides the first three. Okay, yes, and we always have to put theta with it because sine function always requires an angle at the end. I remember Mr. Grant, remember when you guys were talking about like log functions here? You guys remember chapter 3 logs? It was always, log of a number, right? No, and some people don't want to remember chapter 3. Yeah. Okay, so we're going to go like this. So sine of theta is equal to, and we're going to use one of those ratios. So the ratio that we're going to use is going to be y over r. Now it's the y coordinate, right, over the r value. So a few things we've got to think about here. Y coordinate, can the y value be positive or negative? Can coordinates be positive or negative? Yes. Can the distance from the origin to the x and y coordinate be positive or negative? Has to be positive. Okay, so in here, the y could be positive, negative. The r has to be positive. Good? Okay, so there's sine. Next one is going to be the cosine. So we call it cosine. Cool. All right. Cosine. What's the abbreviation? Yep. COS. COS would be the abbreviation. We still call it cosine. You don't call it cos, but it's cosine. And what's going to be the ratio that, yes, that Hipparchus used, that we use ever since, is x over r. Sweet. Yep, it could be. The next one here. So again, we're just using Hipparchus's definitions. We've used them ever since. Good. So next one is tangent. Tangent of theta. Abbreviation? Tan. Yep. Abbreviation would be abbreviation with TAN, but we still call it tangent. Tangent of theta. And anybody want to guess the ratio? There's no Z. Ooh, interesting. So it'll only be two numbers. Sounds good. I think I heard it here. Y over X is just the coordinates themselves. Now this one's a fun one because Y could be negative and X could be negative, right? So there's actually a weird little thing that happens here, right? If they were both negative, you actually get a positive ratio out of it. That kind of throws an issue there. Okay, so we got tangent. What else? If we have tangent, we have cotangent. X over Y, perfect. So what? Oh, sorry, abbreviation first. Yeah, COT, right? COT would be the abbreviation. And it is X over Y. So what? This is kind of not making sense because sine is Y over R, right? But the co of sine is actually, it's not over Y, it's actually X over R. Oh, man. So the next one. There's 6 of them, right? Aren't there 6 ratios to a triangle? Right? So we have Y over R, we have X over R, we have Y over X, we have X over R. What's the missing part? Yes, R over X is missing and R over Y is missing. Okay. Oh, no. Here we go. It's called secant. Secant of theta. So where these numbers come from, tangent, it just means touch. And it's SECANT, the abbreviation that. The abbreviation is SEC, just like seconds, right? And this one's going to be R over X. Huh, interesting. Oh, yes, good. And then we call it secant, right? So cosecant. Cosecant of theta. So we're going to get these interesting terms here. So yeah, SEC is our form for seconds, right? Oh, hold on. We got ourselves a problem, guys. Hold on. So if we take the first 3 letters, are we in trouble? Yeah, we get cosine. Not good, not good. Cos. That'd be 4 letters. Okay, so here's what we decided to do a long time ago. We decided to drop the first 2 vowels. What are we dropping? The O and the E. And we're just going to go CSC. And there's lots of confusion here, right? Look at that. So the sine and the cosine, tangent and cotangent, I can understand that, right? Tangent, cotangent, they flip each other, right? But then, okay, the last one would be R over Y. So there's only 6 ratios. Do we have all 6 ratios? Okay. So yeah, so that's weird. So tangent, cotangent, I understand this. This totally makes sense here. But then why this guy has the Y value and then this has the R, but they're the cos of it. And this is the cosine of sine. This is the co of the secant, but then they actually go, hold on real quick here. Cosecant actually is the reciprocal of sine. It goes all the way up here, doesn't it? It's like that. And then secant is actually the reciprocal of cosine. Oh, man. And then these two, so actually the outer rims out, I think that's a movie. They are reciprocals of each other. The first 2 and the last 2 are reciprocals of each other, and then the middle ones are reciprocals of each other. Are we good? There's the start of trigonometry, guys. So, okay, let's go with it. So let's start using it. Let's go with it here. So can you? Oh, this was just a little blurb here. Is it in mathematics? Sine is a trig function. The word sine in Latin is, thank you, comes from a Latin mistranslation of gibba. which is a transliteration of a Sanskrit. There you go. It was a Sanskrit word originally. So um, we knew about sine, we knew about trig, we knew about ratios, right? All the way back to Sumerian culture. But it wasn't until Hipparchus actually wrote it down, made 12 volumes of tables, right? That he figured, okay, he's the founder, he's the guy that have 12 books behind his name, right? So we give it to him. Okay, so at the end of the semester, you guys are to do a presentation, and the presentation is going to consist of um, one of three things. You could do it on a mathematician that has something to do with trigonometry. You can do on a topic that we discussed in class or was in the textbook that you just found fascinating. Like, this is so cool, and you just dug deeper into it. We're good? The third part is you could do, like this one would be this one right here. Like, oh, sine curve, what? I want to see where did the mistranslation come from? How did it happen? Who did it? Who's the guy that did it? Okay. And then the other part is you can take trigonometry, what we studied so far, and apply it to a real world situation, something you're familiar with, something that's kind of cool, right? My favorite one has been about skateboards, right? Skateboards have angles to them. The trucks are either really rigid or loose, depending on that and the height of them. And based upon that, you have all these different classifications of skateboards because of that. So it deals with angle, the rotation of the angle on a skateboard. Anyway, yeah, as long as it ties to trigonometry. Yeah, sweet. No, there's some pretty cool projects. I'll give you guys some along the way. Individual, and you're going to present it to the rest of the class. Okay, let's go on. Here it is. So can you, exercise 1, state the 6th trig. Oh, you know what? In this class, we always have lots of, no, it's like lots of fun with functions. Don't we? Okay, go with it here. So there it is. That's all I'm given right here. State the 6 trig functions based on that right there. I don't have an R. I don't have an R. Oh, that was cool. So -1, 3. Okay, I guess I can draw it, right? Because I see you guys drawing it. I can draw it out. So negative, which quadrant? That one. That one. Top left. Yeah, that'd be quadrant 2. That's right. Okay. Cool, cool. Okay, so let me list out, depending how we want to finish, let me list out all the trig functions, right? So it's sine theta. I need cosine theta. So now notice on this one, I'm not putting a parenthesis around it. You could put a parenthesis, you could put not. It just depends on you. Good? So I got myself this one. I got cotangent. I got secant, and I got cosecant. There it is. I'm missing an equal sign. There it is. Okay. Now I'm ready for it here. So -1, 3, 1, 1, 2, 3 is right here. Here's my little dot, and there is my little line back to the origin. Anybody got an answer for R yet? How do we get an answer for R? Cool. What's the answer? Square 10. Okay, sounds good. Oh, remember this right here? Remember we have to put this little curvy arrow. Is that right? The curvy arrow has to get there. Just the distance form, yeah. Since there's a few things here. So we need the curvy arrow because we need to know which direction it went and how far, right? We also need to put down that it's a theta. We need to put down that it's actually an angle measurement here. So there's that. And the R value, distance formula, here it is. Now, here's a little quick bit about the distance formula. We're going back to the origin, is that right? Origin is 0, 0. So if you are at -1 along the x-axis and you subtract 0 from it, you're still going to be at -1. So I'm going to just put -1 squared and then 3 squared. Then let's see, -1 squared is 1. If you wanted the distance formula for anything that goes back to the origin, right? You don't need to include the 0, so you can just write x squared plus y squared and take a square root. Okay, let's see, 1 squared is 1. That's going to be a 9, and Adrian said 10, and I totally agree. Does 10 have a perfect square inside it? No, huh? Because 10 is made up of 2 and a 5, and that's it. Right, okay, so we'll stick with r being that way. Next, let's go with it here. So I'm going to go with it. So sine is the y coordinate over the r value. Is that right? Sweet. Okay, are we good there? Are we all done? So kind of careful, because some people put like 3 as the sine theta, but it's actually 3 over the root of 10. Is that right? It's a fraction. Okay, cosine. Anybody give me cosine? Perfect. -1 over root 10. Now notice also, hey, Mr. NG, you are not rationalizing your denominator. True, true. You could rationalize the denominator if you like to, but normally we are not going to rationalize the denominator. Good? Tangent. Anyway, answer for tangent. Cool. Now this one we do have to simplify because they're both integers, and this was simplified too. I go with the -3. Cotangent. Yep, and then we can leave that. That does not need simplification. Next. Root 10 over -1. This one does need simplification. How about a negative root 10? Are we good? Dun, dun, dun. And the last one. Perfect. Okay, so notice the ones that we simplified, notice the ones we did not, right? Anytime you have a 1 or a -1 on the bottom fraction, yes, we simplify. Anytime we just have integers that can go into each other, we simplify. Okay, are we good to go here? Tell me if I'm going too fast. Okay, for each one of these here, we're going to do one, but then I'm going to add an extra little something to it, okay? So, B. And tell me if I'm going too fast. We good there? I'm not going to give you C yet here. I want you guys to do B. So you guys can work it out and then check with the person next to you to make sure you have worked it out correctly. Have to do exactly what we did for A, right? So graph it. I need to know that little bend of the arrow, right? I need to label it as theta. All right, I'm going to walk around, see how you guys are doing, and then eventually I do want to see sine, cosine, tangent, cotangent, secant, cosine. Oh, nice. What did the R value turn out to be? That is a ratio, right? 3, 4, 5 ratio. People that are almost done or halfway done writing their trig functions here. All right, I'm gonna put down some of the answers here. So if you want to get started on this next one, that's fine. And I'm going to give you guys the answers to this one here. Since you guys are done anyways here, I got this one right here. There's my 3D So I'm going to write this. The R value. We had an R value of 5 because it was 25. Perfecto. Right there. And then can you also do 6, 8 for me? All right, you guys know some interesting things that happen, right? That was the whole point of this here. The only thing I forgot for my first angle, I should have done this here. I need my my rotation. Is that right? I also need to label the the angle measurement. There it is. Okay. Looking at the room just real quickly here, I see most people are finishing up. They're starting their trig ratios or in the middle of doing their trig ratios for C. Okay, so let's go then. I'm going to do this next one here. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8 on top. I get over here. I do that. And then it's kind of forming a triangle here. I am still forgetting this little guy here, so I should put it in. Where did it go? Yep. My rotation has to be here. My curvy arrow has to be here. And I have to label my theta. What'd you guys get for the answer for R? 10. Perfecto. And here's the fun part that happened, right? And tell me if I'm going too fast. I can slow down, okay? So sine is technically my y coordinate over my r value, which is 8 over 10, which is 4 over 5. Hey, that is no fun. Or maybe fun. So this is going to be 6 over, hold on, 6 over 10 or 3 over 5, is that right? And I can probably just do 3 over 5. And then what else can I do at this point? Can I just copy B? Copy B, absolutely. 4 over 3, yes. 3 over 4, yes. 5 over 3, yes. And 5 over 4, yes. Okay, tell me, anybody in English, what did we just see? The 3, 4, 5 ratio is the same. Okay. Okay, okay. Gotcha, gotcha. Awesome. You guys are saying it here. Anybody else want to just kind of phrase it that what makes sense in your mind? Does it make sense for others? Okay, so, and what do you mean by double? What does that mean? What do you mean by? Okay, so my B triangle looks like this. True, true, right? And then my C triangle is twice this right here, right? So it's actually over here, and then it's twice this, right? Does it still form the exact same angle? Oh, the angle's the same. Anybody remember this from not learning geometry, but can kind of guess? What is this called right here? Thank you. These guys are called similar triangles, right? Similar triangles means that the size could be different, right? But the shape is exactly the same. Cool. So okay, so similar triangles are going to give me the exact same trig ratio. Are we good? Sweet. That is awesome. Okay, next, this one now. 5, 5. Can you give me an answer to 5, 5? Let's see. That's some fun stuff here. Yeah, if you so first of all, simplify the R value as much as possible, right? And then simplify the ratio as much as possible. Yeah, so if there's any perfect squares that are sitting inside the square root for R, you have to simplify that out. All right, let's do it together here as well, because I see some people are already almost done and some people are kind of working with the way through it. Tell me if I'm in the right track here. This is 5, we're in quadrant 1. Here's all my trig ratios. Hold on, what? I can't write that in there yet. That's to give away the problem. Okay, I'm going to do that on the board here. Let's see. So I got to do like this. Sine theta, is that right? Does this take a long time to write all those 3 trig ratios out? This is the way the book lists them. So it'd probably be easier just to go with the way the book does it each time. But what did you mean by that? Oh, gotcha. On the test, I want you to. But if it makes sense to you to just write them out, that's fine. Okay, I'm gonna go like this, right here, boom, right? I need to do that, and I need to do this to say that's theta. Cool. Next is R value, right? R value is 5 squared plus another 5 squared. That's nice. That's 25 plus 25 is 50. And 50, 2 times 25. Perfect. Yep, if they're the exact same number, it is always going to work out to be that way. So sine ratio. Oh, let me put all the figures in here. So this is 5, 5, and this is a 5 root 2. Okay. Y over R, is that right? And then what I can do is can I reduce the 5s? Yeah, as long as it's not addition, right? As long as there's no addition. If it was like a 5 plus 7 over here, then no, I couldn't do it. Oh, that's funny. So sine and cosine are exactly the same, is that right? Okay, that's cool. 1 over 2. Tangent is, oh, this is even more funny. This is just 1. And then this one's going to be the exact same thing. Okay, this one's going to be R value this time over, anybody? What's secant? 5, yeah. Secant, 5's cancel. I'm just with the regular root 2. And then the same thing on this side. Is that right? Okay. Cool. We might notice a little something here. All right. All done. Is that right? Just asking. Do we know what this angle is? Oh. The value of the angle is 45 degrees. How come 45 degrees? It's half of 90 degrees. We know because the coordinates are exactly the same, right? And that's the diagonal going across our x and y grid, right? The Cartesian coordinate plane, right? Cool. Okay, so hold on. So then can I really say this? It doesn't matter what the triangle will be. It actually doesn't even matter on the coordinates. The coordinates don't matter. Is this true? Is it true no matter what? Yeah, I think so, right? Because remember, similar triangles, no matter how big this is, if this went out to 28, 28, we would still get a ratio of 1 over root 2. Yep, okay. Next one on the list then to do. Okay, so then let's do this here. Let's shift from points on a plane, and we're going to go to degree values. Whoa, can't show you that. I'm showing you that. Never mind. Okay. So would you guys agree with this right here? If I said a 45-degree triangle. Oh, hold on. Don't we have, besides Sabila, I don't think you have it. We have a 45, 45, 90 triangle. Is that right? So if I were to replace it on a, one second, let me see what I want to do here. I couldn't give you the answer right away. That's no fun. I need to do something or other first here. So you guys tell me if E is correct. Is E correct? So let's see. I'm going to do this here. So a 45 degree angle. Notice that this one is not theta anymore. It's 45 degrees now. Good. So what I do is the easiest one to use for us is just r is equal to 1. We're good. We can make r equals to anything, right? But it has to be like a root something or something, right? It has to be like a 5 root 2 or something, right? But the easiest one to do is 1. So if I can do that, I can now say that sine of 45 degrees is still going to be the exact same thing. Okay, talk to me. I'm not sure if I'm explaining that super well or not. Does E make sense to you guys? And ask me any questions from E. I'm going to give you something else for E in just a second here. Say that again, Kara. Say again. 1 over root 2. Uh-huh. Oh, absolutely. Yeah, that's a huge part of trigonometry. Uh-huh. So you guys that have a 45, 45, 90 triangle. So I have this, and if you guys don't have one yet, that's what we did on Friday. I'm going to make one for you. Okay? So here's what we do. We just think about this little guy right here being a 1, right? We're going to place our 45 triangle like this. Okay? And this is side length of 1. And we're already going to know what this is right here. Okay? Another interesting part is this. If that guy is the y coordinate, and this is 1, let's come back over here. This is my y coordinate. Do I need to put a 1 on the bottom anymore? No, right? Because that over a 1 is just going to be that again. Okay? So then same thing for cosine. Cosine is my y, my x coordinate. There's that. And now you get to put this down. I don't need a 1 on the bottom anymore. Right? Because 1 is just going to be divided. Now for tangent, every okay with why this is a 1? It's this number over the exact same number, right? It's until 1. Okay. For cotangent, the same thing. Or can I just do this? Can I, as soon as I know this one, can I just flip it around? Cool. And then as soon as I know this, I can flip that around. And then go from there. Okay. Here's your. Kind of feel like E star because I'm going to change this one up here. So I need you guys to find this right here. So, okay, you guys talk to me here. Did E make sense to everybody now? Once you get your little triangle in place, right? Then you know the lengths of the sides. Once you know that, then you know your coordinates, right? Once you know your coordinates, because you have an r value of 1, you actually don't even need to write the 1 down, right? If you don't need to. Right? Okay. Yeah.
So there's a different like number for each of the angle things. So like a 50-degree angle would have different ratios.
Yes.
But they'd always be the same. Right.
They would still have to be a ratio of the triangle whole, right? That's why the 45 is so important, because that one we actually get exact values. For a 50-degree angle, there's no way from geometry to get an exact value. Right, because it's this little piece right, it's going to be down here, so 50 degrees would be right here, right? But that's why this is so special, right? From geometry, I know the exact length of the side. I know the exact length of the side. Okay, your job. I need to know. I'll put E star. Okay? Star means we're kind of doing the same problem, but a different way. Okay? I need to know this. I need to know. 135. I need to know all the trig ratios based upon the angle measurement of 135 degrees. So I need all the trig measurements based upon the angle of 135 degrees. Okay, as you get started now, I'm going to do it. So some of you guys can be super fast in it. Like, oh yeah, that's easy. Done. See again? But no, we should be able to get this just quite easily as we do it. Man, we're doing some fun trig stuff now. So I need to know all the trig measurements based upon an angle measurement of 135 degrees. Okay, I'm going to do this here real quick. I'm going to set up another screen for me because E, I thought I had. I'm going to go like this. Actually, no, yeah. All right, let's do it together then. So I got E star on my hands. Boom. 135 degrees. I wonder what happens here. Why did Mr. G get a special angle 135 degrees? I'm not sure. So let's go for it here. So which quadrant? 2, yeah. So this would be quadrant 1. This is quadrant 2. We have quadrant 3, Roman numerals. Quadrant 4. And 135 degrees is right here. In fact, hold on. Is it 45 degrees more than 90? Is that right? So I'm going to go like this. I got to do 135. I got to do this right here, right? Boom, boom, boom. And then similar triangles means I can go out as far as I like for R, right? I can come in as short as I want for R, right? But the easy one I'm going to use is 1. We good? So if you need to use your 45, 45, 90 triangle. So hold on, if this is 45 degrees, right? Isn't this right here 45 degrees? Okay, I think I like this. So if that is a 45-degree angle, if I drop down in altitude, and this is a right angle right here, this would also have to be, love it. Okay, from geometry, you tell me, from geometry, it's a tricky question. From geometry, based upon my 45, 45, 90 triangle, what are those exact coordinates? Slightly tricky question. Thank you. Yes. The 45-degree triangle, right? This is a positive value, right? But we're going to the left. So, and Adrian, which one did you say? 1 over root 2? Okay. So you could either put root 2 over 2 or you could put 1 over root 2. It wouldn't matter. The book kind of flip-flops all the time between those, okay? So just depending which one you want to use, right? Just get comfortable with one of them or both of them here. So that is a negative 1 over root 2. Adrian said it correctly. Try to trick him. Couldn't trick him. So are we good there? So let's go with it. Sine, now sine of 135 degrees. Cosine of 135. I'm going to write them all down here. Tangent of 135 degrees. Now, do they need parentheses around them? Yes, technically, if you want to, but as long as you know you're taking the value of those here. And yeah, that's right. The one with the vowels missing. There you go. Okay. Okay. Because R is 1, we really don't even need to include the 1. What is sine of 135 degrees? Oh, and if you want it for your notes, we good? If you want it for your notes, here it is for your notes. It's going to be the Y value over the R value. The R value is just 1, and because of that, we just need the Y value. Does that help out? Kind of thoughtful. So that is just going to be 1 over root 2. This would be the X over the R value by definition, but the R value is 1. Perfect. So we just need the X value, which is negative 1 over 2. By definition, we actually need both of them. This is Y over X, and this will be a 1 over root 2 divided by a negative 1 over root 2. Same exact number, is that right? Except the sign is different, right? So how about a negative 1 at the end? All right, I'm going to have to kind of scoot this around a little bit here. This is X over Y. So this now is a negative 1 over root 2 on top, positive 1 over root 2 on the bottom, still a negative 1. Are we good? Oh, how fun. Okay, this one. Let me write it down below here. Let's see. Let's see if I can erase. Ah, gotcha, PowerPoint. Okay, I'm going to write this one here. So secant of 135 degrees. By definition, it's R over, anybody? X, perfect. This is 1. So it's 1 over negative 1 over root 2. Oh boy, what do we do here? We just flip it around. Okay, so let's go back over here. So if I have like a 1 over, this is from my own brain, are we good? Kind of scary sometimes, but this, if you have a 1 on top and you have that on the bottom, that is the same thing as the flip of your denominator. Good? Just flip it over and you're done. So 1 over that fraction becomes that, which becomes just a negative root 2. Or we could have just flipped this over, right? That would have been the flip of it. Be done. Okay, this one. Again, putting in all the values here, R over Y. R is 1, so just 1 over a Y value. And the Y value is 1 over root 2. Flip it over. And we got ourselves our final answer. Are we good? Yes. Awesome. Super cool stuff. I think we're doing some pretty cool, nifty trick stuff. So I got another angle for you. I'm going to just go 15 degrees further down the line. So we draw our little grid system. And the question really is there a way to find the exact coordinate? Find the exact coordinate. You guys talk to me. I do want to say, I get excited about trigonometry. So sometimes we just go on lecture. It's kind of cool stuff. So like we didn't get to the homework still. So if you still don't have 1.2 done, that's okay. We'll handle it on Friday. We'll catch up with this. We'll finish this up, and we'll kind of put everything together. Okay? So not too seriously. And then, I mean, if you're like 3 days behind on homework, that's fine. You know, after the due date. Okay. So you don't need. If you still have questions on 1.2 homework, don't turn it in. Is everybody okay with 1.1 homework? Everybody? Okay. Just want to make sure that's done. Did you have a question?
No, I had a question.
Okay, good. Go for it. Answer is.
The coordinate is 1 over 2 from square root of 3 over 2.
Yes, awesome. How come you got A's?
Because
Okay.
the complementary angle, or supplementary angle, another angle,
Yeah.
150 degrees place is 30 degrees.
Uh-huh.
The base of 3690 triangle. And then the sides are 3690 triangle.
Okay, are we good? It's not the 45-45 triangle anymore. It's this guy here from geometry, right? So if we place this angle like this, is that right? That'll work. So, and we'll set it best here. It is the supplementary angle, right? We have 150 degrees this way. That means the extra piece here is 30. Cool. Okay, let's go with it here. So I'm going to write them out again. Blah, 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 and blah, blah, blah. Right, and then blah, blah, blah. So I go all the way out here. This guy has to be 150 degrees, but if that is the case, that means this guy has to be 30. Awesome. I'm going to place a dot like in space. We good? This could just be that. That's a 60 degree now. And we have ourselves that little ratio right there. That's the ratio I want. Okay, if that's 1, so that means at that corner right there, at that point right there, that should be a negative, right? The distance is, oh, that's right, opposite my 30 is the 1/2, right? Opposite my 60 is the √3/2, but we're in quadrant 2, so therefore it has to be a negative √3/2, comma, positive 1/2. Are we good? Does the coordinates make sense? And please ask away if we don't. So it's, again, built upon geometry, right? Built upon that 30, 60, 90 triangle. Guys, and that's it. If I can't form a 45, 45, 90 or a 30, 60, 90 triangle within one of those quadrants, I can't know the exact value. Good? Okay, answers are. Let's go with it. Sine value is? Sine value is the y coordinate, is that right? We forget about the r value. So y coordinate? (1/2). Perfect. Doom. The x cosine of 150 is? Negative √3/2. Perfect. Tangent. Oh, tangent. Oh boy, maybe this is going to be a little bit complicated. So tangent is going to be the y coordinate over. Okay, just got complicated. Perfect. Okay, so here it is. If you guys have, so back to some fundamental math stuff here. If you have two denominators right here that are exactly the same, what you can do, those denominators go away, and you can just work with each of the numerators. That's exactly what we're going to do here. We're going to get rid of the 2's. Is it time already to leave? Sheesh. Okay, so 1 over negative √3. Okay, the other way. You can just flip this over, can't you? So we'll do it the easy way. Yeah, just flip it over this way. Boom. You could just flip over this one. This gets flipped over. Oh, and then what's the flip of 1/2? 2. Absolutely. And there's the answer to that one. Okay. We gotta finish here. Okay. Was that cool? Cool. Just based upon triangle. Let's do this here. I'm going to send you guys the homework that you guys can start on in 1.3. Okay. I'll send you guys a list, and then you at least can start on the homework. And let's do this. We'll wrap up 1.3 on Friday. We'll wrap up 1.2 homework on Friday, and we'll wrap up the rest of all that good stuff. Don't turn it in yet. If you have questions on it, don't turn it in. If you don't have any questions, you can turn it in. Absolutely. But if you do, please let us know. Okay. Yeah, absolutely.